Good day, everyone. My name is Tutor Dan, and we'll be looking at the topic multiplication of matrices. Now, multiplication of matrices is of two types. Number one, we have the scalar matrix, scalar multiplication rather. We have scalar multiplication. And then number two, we have multiplication of matrices. Multiplication of matrices. Now, if you look at scalar multiplication, it's quite easy and quite simple. So scalar multiplication is more like you having a single digit multiplying a matrix. Right? So for example, if I have A equal matrix 3, 2, 1, 0, 5, and then minus 2, for example, right? Scalar multiplication of matrix A is getting a single digit, say x, to multiply A, right? So that for x to multiply A is just multiplying x, all the elements of A by x, 0, 5, and minus 2. So if x, let's say x equal 5 now, for example, for 5 to multiply A, simply means 5 will multiply every element of A, 3, 2, 1, and then 0, 5, minus 2. So that 5 multiplying A will equal 5 multiply each element, 5 times 3, 5 times 2, 5 times 1. 5 multiplies 0, 2, 5 multiplies 5, and then 5 multiplies minus 2. So that 5 multiplying A will now equal 5 times 3 is 15, 5 times 2 is 10, 5 times 1 is 5, 5 times 0 is 0, 5 times 5 is 25, and then 5 times minus 2 is minus 10. And then this becomes the scalar multiplication of A by 5. Now, when we have multiplication of two matrices, right? Multiplication of matrices, say, not two now, multiplication of matrices. That is when two matrices have to multiply each other. So the first thing you need to note is that two matrices can only multiply each other if the number of columns in the first matrix is the number of rows in the second matrix. So for example, we want to multiply A and B together, matrix A and matrix B. Matrix A can only multiply matrix B if, for example, A has 3 columns. Then B must also have 3 rows. So for this multiplication, we are not necessarily concerned about the number of rows in matrix A as well as the number of columns in matrix B. So for example, if A is an n by n matrix, that is, it has n number of rows and has n number of columns. For A to multiply B, B must have the row, this row must be the number of columns in A, then by maybe P, any number of columns. So the number of columns in A is the number of rows in B. The number of columns in A is the number of rows in B. So for example, if A is equal to matrix now 3, 2, 5, and then 1, for example, and then we have 6, 4, 1, 2. Now, sorry, 6, 4, 1, and then 2. Now, if you notice this, A has how many rows? Two rows. We are not concerned about its number of rows, but we are most concerned about its column. We are very much concerned about its column. So A has four columns. So A is a 2 by 4 matrix. So this 4 is the number of columns in A. It means that for A to multiply B, B must have now not 4 columns but 4 rows. So it can have any number of columns. So let's see, B must have 6, 8, 3, for example, 2, 4, 9, 6, 1, minus 3, minus 2, 0, and 4. So it has, this is how many rows now? We are concerned about the row 1, row 2, row 3, and this is row 4. Right? This is column 1, this is column 2, this is column 3. So matrix B is what? An order 4 by 2. So now the same number of columns is the same number of rows. Then A and B can multiply. Take note, two matrices A and B can only multiply themselves if the number of columns in A is the number of rows in B. So to now do this multiplication, we multiply row by column. So now A dot B will be row 1 multiplies now column 1, we have row 1 multiplies column 2, right? And then, yes, and then row 1 multiplies column 3. Now, row 2 now is, it has, matrix A only has 2 rows. So, row 2 multiplies column 1, row 2 also multiplies column 2, right? And then row 2 multiplies column 3. And this is how to perform multiplication of two matrices. So you are careful. All elements in row 1 multiplies all elements in the column. So we are doing row by column. So to have this multiplication done, we know that A is equal 3, 2, 5, 1, 6, 4, 1, and 2. And then multiplying it by B, which is equal now 683, 683, 2, 4, 9, 6, 1, minus 3, then minus 2, 0, and 4. Okay. So now, in this case, A cross B, A multiplying B will equal now 3 multiplies 6 plus 2 multiplies 2, right? The first element multiplies this plus this multiplies this plus this multiplies this plus this multiplies this. So we have 3 multiplying C plus 2 multiplying 2 plus 5 multiplying 6 and then plus 1 multiplying minus 2. Now, row 1 will also multiply column 2. So which means we have 3 multiplying 8 plus 2 multiplying 4 plus 5 multiplying 1 and then plus 1 multiplying 0. Here, row 1 we also multiply column 3 so that we have 3 multiply 3 plus 2 multiply 9 plus 5 multiply minus 3 and then plus 1 multiplying 4. Sorry, excuse me. So 1 multiplying 4. And then that's it. Now, root 2, we do likewise. So root 2, we multiply column 1, multiply column 2, multiply column 3. Please excuse me. So we have 6 now, multiplying 6, 4 plus 4 multiplying 2 plus 1 multiplying 6 and then plus 2 multiplying minus 2. Root 2 multiplies column 2. So we have 6 multiplying 8 plus 4 multiplying 4 plus 1 multiplying 1 and then plus 2 multiplying 0. Root 2 will also multiply column 3. So we have 6 multiplying 3 plus 4 multiplying 9 plus 1 multiplying minus 3 and then plus 2 multiplying 4. So we cannot do the addition. So we do the multiplication and addition rather. So we now have A cross B will equal 3 times 6 is 18 plus 2 times 2 is 4 plus 5 times 6 is 30 plus 1 times minus 2 is minus 2. So we have minus 2. So we go 3 times 8 is 24 plus 2 times 4 is 8 plus 5 times 1 is 5 plus 1 times 0 is 0. So for the next one, we have 3 times 3 is 9, 2 times 9 is 18, so we have plus 5 times minus 3 is minus 15, so we have minus 15, and then 1 times 4 is 4, we have plus 4. Now, we are getting there already. 6 times 6, second row now, is 36, plus 4 times 2 is 8, plus 1 times 6 is 6, plus times minus is minus 2 times 2, that is minus 4. 6 times 8 is 48, plus 4 times 4 is 16, plus 1 times 1 is 1, plus 2 times 0 is 0. Now, third column, 6 times 3 is 18, plus 4 times 9 is 36, plus times minus is minus, 1 times 3 is minus 3, 2 times 4 is plus 8. So we can now add them together so that we have A cross B will equal 18 plus 4 is 22. 22 plus 30 is 52. 52 minus 2 is 50. So that is the element in the first row, first column. So 24 plus 8 is 32. 32 plus 5 is 37. 37 plus 0 is 37. Now, 9 plus 18 is 27. 27 minus 15 is 12. 12 plus 4 is 16. So we have 16. Now we have 36 plus 8 is 44. 44 plus 6 is 50. 50 minus 4 is 46. So we have 46. Now 48 plus 16 is 64. 64 plus 1 is 65. 65 plus 0, that is 65. 18 plus 36 is 54. 54 minus 3 is 51. 51 plus 8 is 59. So this will be the result of our A multiplying B. It's not difficult, it's a very simple one. First, take note that A can only multiply B if the number of columns in A is the number of rows in B. So the next thing is to multiply each row in the first matrix multiplies each column in the second matrix. Thank you very much for joining. I'll see you in the next class. Bye for now.